Hi, everyone, and welcome to today's online training session from SimActive. My name is Simon Grandin, and I'm the photogrammetric workflow specialist here at SimActive. So today, the topic of my online training session will be accelerating volume measurement with UAV data. As you may know, volumetric calculation is in demand in many spheres of our industry, such as mining industry, forestry, or construction industry. So today I will give you some tips on how you can accelerate all your volume measurements and also have more precise measurement for your customers. So for this presentation, we will cover the following topics, such as understanding the requirements for precise measurements, how to do some volumetrics calculation in Correlator 3D, using a proper reference elevation for your volumetric calculation, how to use script for your measurements, and finally, we will finish with some case scenarios on how you can measure volumes with Correlator 3D. So let's start this presentation by understanding the requirements for precise measurement. As you may know, in photogrammetry, the input data is the most critical part of having accurate and precise measurement for 3D volumes. As you may know, with Correlator 3D, we usually recommend having some parallel flight lines with probably 50% side lap overlap and 70% front overlap. This is the minimal requirements for UAV to make sure that you have a good reconstruction of your model. Also, when we talk about the accuracy, sometimes there's a misunderstanding of the concept of what is really the accuracy of your project. So basically, the accuracy can be break down into two types of accuracy, such as the relative accuracy and the absolute accuracy. The relative accuracy states for when how well your block of images is all tied together. So it's really depend on the quality of the tie points that we were able to extract between the images, and also, so it's referred to the relationship of individual features, one to the other one, and also a good relative accuracy. It could be achieved by measuring a distance, let's say, between 2 points in your map. The relative accuracy depends on many factors, such as the overlap of your project, the visual content of the imagery, and also the quality of the images that you will bring into the software. So you want to have, as I said before, a good overlap, so between 50-70%, and you maybe in some cases raise this overlap to maybe 60% side lap, 80% front lap, but you don't want to go too much with a high overlap because you will reduce your base height ratio, and this also will have an effect on the vertical accuracy of your reconstruction. You want to have good visual content of the imagery, so you don't want to have images that are overexposed or underexposed. When you are flying, you want to have good weather condition, such as you don't want to have shadows into your scene because the shadows can also create some artifacts during the matching. Having a good overlap will also reduce the occlusion that you could have between two different images. So basically, you can see multiple points for at least 2 points of view and more. And then you also want to have a good ground sample distance, which is the main key here on how well you will be able to extract the accurate 3D volumes from your model. The other type of accuracy that we have talked is the absolute accuracy. So how well your locational accuracy of your map is comparing to the true position on the Earth. The absolute accuracy can be assessed by using ground control points. So the ground control points will help you to enhance or to have a more accurate overall accuracy for your photogrammetric project. You can also use some checkpoints to really see or to assess the quality of your overall aerial triangulation, and also the accuracy, overall accuracy could be achieved by using UAV with PPK or RTK data, and that are also used with checkpoint to validate the overall accuracy of the project. If you're using ground control points, well, the goal here is to have a good amount of ground control points. It's really hard for us to say an appropriate numbers uh, for the photogrammetric project because it depends on many factors. But you want to have your ground control point well spread out throughout your mapping area because you want to if there's you want to distribute um, the accuracy overall your mapping product. You don't want to have them clustered only in one section of your project because the error, if there is one, will be spread out throughout all the rest of the project. Um, and finally, one good thing is when you're done your aerial triangulation, you really need to make sure that you will analyze the quality reports of your project. So as you can see here on your screen, you will have on the first page of your quality report, three different windows that you can assess the overall accuracy of your project. So you can take a look at the tie point residual, so how well your block of images is matched together. You can see also the number of images, the number of tie point also give you a good information about the redundancy of your project. So in photogrammetry, is usually good to have more redundancy than less because it's a key part for a good reconstruction. If you want to assess the overall accuracy of your project, you may take a look at the ground control points residual. So you will have all your errors that will be assessed in planimetry, in vertical, and also the numbers of GCPs. If you're using checkpoints, which I think are the most valuable source of information to validate the result of your AT, because ground control points will be used during the bundle adjustment to compute or to help to achieve a better overall accuracy. As of checkpoints, they will be there only to validate the overall accuracy of your project. So when you're using checkpoint, it's really those numbers that will tell you how much your project is precise regarding your survey that you did on the field. Also, the overall accuracy is depending then many other factors. But as for the checkpoints, you cannot have the quality of your survey will really relies on how much your project is accurate or not. Now that we have talked a bit about understanding the requirements for precise measurement, let's jump into the subject of our today's online training session, which is the volume calculation in Correlator 3D. So in Correlator 3D, you can measure volumes from two different ways. You can either measure your volumes from the graphical user interface, or also if you have many volumetric calculation to perform, you can do them with script that will be running from the command line. If you want to perform also those types of measurements, there's three elements that are required. At least two are required, and the third one is optional depending on the type of analysis that you will perform. But you at least need a digital elevation model that represent the area you want to map. You also need a stockpile feature, so a shapefile that corresponding to the area that you want to measure your volumes. If you don't have one prior to doing your survey, you can also draw all your polygons into Correlator 3D. So it will be done interactively in the map. And if you want to perform time change analysis to see how your volumes has changed over a few different dates, you will need an external DEM. Let's say if you're comparing two dates, you will need one elevation data at the date one, and another one at the date two if you want to compare the change between those two dates. Also, when you will measure your volumetric calculation in Correlator 3D, the user have have a few options to perform those measurements that will have an effect on the accuracy that you will measure your volumes. So there's 6 options. So basically, the first one is interpolate them at the polygon boundary. So what the software will do is when you will draw a polygon, it will interpolate at the vertices of your polygon. It will interpolate, or it will take the elevation from the digital elevation model that you will use, and it will use this elevation as a reference for the volumetric calculation. It could also interpolate at the polygon elevation. So let's say your polygon are already drawn prior to do your survey. So you can bring in a 3D shapefile with already containing elevation features for every vertices. And you can use this elevation vertices as a reference for your volumetric calculation. You can also use a fixed elevation or a constant elevation throughout all your stockpiles. You can remove or add a constant offset in your shapefile. So let's say your stockpile is in a bin, and you also know the depth of the bin. Well, you can remove this constant offset or add another constant if you want so. And the last option is if you're performing time change analysis, well, you can import a reference DEM that will be used as a start date, and then the other one will be used as an end date. So now let's see how it looks in Correlator 3D if you want to perform volumetric calculation. So a quick overview of the software. So as you can see now, we have the graphical user interface of Correlator 3D. So I have on the left here, I have all my project tree, which contain my images, my ground control points, my DEM, my mosaic, my ortho rectification, and I also have some features that will be used for the volumetric calculation. As you can see on the map at the moment, I have 5 GCPs that were used for this project, and those GCPs are quite well spread out throughout this project. So I'm quite confident that the accuracy that I will obtain for my measurement will be highly accurate. So on the top left here, you have all the modules. So you have the open and close project. We have the automated workflow that I will come back just a bit later to show you how to create some script. Then we have the arrow triangulation button. We have the DEM generation, so the DSM, the DTM extraction, and the DEM editing. We have also the ortho and the mosaic creation, and also the mosaic editing, and the 3D model generation. If you want to perform volumetric calculation, we have actually the volumetric module that is around here. And also on the left, we have, if you want to draw some topographic profile, you can use the tool next to it. So by going into the volumetric modules, you can open this module and draw some polygons within this module. So I could draw a polygon like this around this feature, and use this polygon to calculate some volume. So I can use the little button measure volume here, and I will have basically the parameters window, and then I will be able to process the volumetric calculation. So as I have here, I have the volume cut, the volume fill, the terrain area, the orthogonal area, and the volume coverage. So basically the volume cut is basically what you have above the reference elevation. The volume fill is what you usually have below. And then the terrain area is the area that's corresponding if you follow the topography. And the orthogonal area is the area without any topography for your model. As I said, also previously to this presentation, you can run uh, volumetric calculation with script. So without even launching the command, the graphical user interface, the user can run the script via the GUI or via command line. So as we can see here, the DM volume calculation have some parameters to play with. So you have here the input dem, so what dem you want to use as the reference. You have the area to map, so what are the stockpiles you want to measure. You have the reference type that you want to use for those volumetric calculation. Depending on the reference type you will use, you can also play with the offset, the elevation constant, or the reference dem. And also you have at the end, basically, where do you want to store your final output text file. So now, if you want to generate a quick script, you have two choices. So the first choice will be to run the automated workflow. So you can run the automated workflow and generate a script from here. And by clicking process here, you will see that with the project you have created, you can generate a script. However, when you do it with the automated workflow, we don't actually add the options to do some volumetric calculation. So if you want to add the volumetric calculation to your script, you can go into the sample file of the installation folder of Correlator 3D. So if I go in my Windows part and I write sample files, you will see a folder with that would contain some script, and inside those script, you will be able to see all the different modules with their corresponding script, and completely at the end of those of this file, I have basically here the volumetric calculation. So I can add, let's say around here, I can add this section to my previous script like this. And as you will see, so when I will launch this script, it will go through the AT, the DSM, the DTM, the ortho rectification, the mosaic creation, and the DM volumetric calculation. If you want to run a script, you can, as I said, either run it with the command line. So if you want to have a bit more info on how to run a script via command line, you can go into the user manual, and we have a section that corresponding to running Correlator 3D with command line. So completely at the end, we have a section on how to run your script. As we have around here. So we explain a bit more the script mode, and then we show you how to run Correlator 3D in command line, and all those different options and the command that you can use while running your script. The other way to run a script is via the graphical user interface. The script can be run via the file, and then at the end here, run a script. It will automatically close your project, so make sure that everything is already saved, and then you will be able to load your script file, and from there it will generate all the modules that were specified in your script. So now that we have reviewed the ways to perform volumetric calculation in Correlator 3D. Let's see a few case of scenario that you could face to perform some volumetric calculation. So the first one will be how to perform only one stockpile. So you only have one area that you want to map. So it's quite the most easiest case to do. You can either draw your shapefile within Correlator 3D, and as I shown before, you will have the volume cut, the volume fill, and all the other information. And this case of scenario can be run within the graphical user interface. So, as I see here, you can go into the volumetric module. You can draw your polygon directly from this module. So let's say I want to draw the modules around here. And also, when you're zooming into a subsection, you can also stretch the histogram of this section to stretch it only on the section you will see. So you can have more precision when drawing your polygon. So I can draw it like this. And then I could also edit the vertices. And from there, I could calculate the volumes by using the interpolate them at the boundary. So as I said here, I have the total. So I have only one stockpile, which I have all is information here. I could save also this information to a text file wherever I want. Let's say if you want to have more stockpiles, more than one stockpile to measure, and you want to have every measurement for each stockpile. So you don't want to have the total of all those. You want to have for each individual stockpile their volumes and their area. You can perform that also with the graphical user interface. So the goal here is to have a shapefile which will contain multiple features inside your shapefile. So as we can see here, let's say you want to create a new shapefile. So let's say I have already drawn a polygon like this, and I want to add one to the specific selection. I could save the selection to a file, and then it will create a temporary selection in my feature tree, and then I could add another selection and draw a polygon. Let's say around the big one, like this here. This, I do it quick and dirty, and then from there, you have two stockpiles that are measured, and you could save here the shapefile wherever you want. So I can go to my desktop and have file this. And for this stockpile that I have two, so I have one at the ID 0 and the other one is at the ID 1. So if I perform the volumetric calculation, well, I have, as you can see here, the polygon 0, which corresponding to the small one. I have his information here. Then I have the polygon 1, which is the big one. I have the information around here. And then I have the total volume. So both of those combined together. And the total volumes of those is usually, if you want to have the total volume, you will need to add the cut and the fill volume together to have the total volumes of your stockpile. Also, if you already have digitized your polygon prior to do all your volumetric calculation in Correlator 3D, you can also import a feature with the little plus button here, and you can specify where your shapefile is already stored. The last case of scenario that we have is basically if you want to perform a time changes between two dates. So the most case here is you really need to be sure that you have an absolute accuracy that is common to both sources. So both sources are well superposed together. So there's no spatial shift between the two sources, because this will also introduce an error throughout your project. So basically, it could be done. Let's say you're performing a flight at the beginning of the summer, where there's nothing in your graveyard, and then at the end of the summer, you have all those stockpiles that were added throughout the summer, and you want to see how much was changed between two dates. So what you can do is you can perform your flight one, take your ground control points on your survey, then do all your processing in Correlator 3D. And at the end of the summer, what you can do is you can do your second flight and use the result of your first flight, such as, let's say, your reference ortho, your reference them, and use them as area where things haven't changed as ground control points. So you will make sure that both sources are well superposed and everything is well accurate together. And you can use, let's say, your DEM at your date one, so at the beginning of the summer, as a reference them, and then you will have basically the difference between those two dates of how much your volume has changed throughout your summer. So thank you very much, everyone, for attending this online training session.